Okay, so we've moved on from Unit 9. We're now into Go Math Unit 10, and we're starting to dabble a little bit into geometry. I want to approach geometry a little bit different than probably you've seen it in the past. And geometry may seem like this far-off thing that's really difficult, right? You have all these shapes to memorize. You have all these equations that you have to solve for. I want to treat geometry as an extension of our algebraic expressions. Okay? So each of our particular equations are just variables that we need to solve. For example, if I have a rectangle, and the rectangle is 4 foot by 2 foot, it doesn't have to be the right size, right? It just needs to look at the numbers that we have. I have the formula area equals length times width. Now I can use that to solve this. Well, what is area equals length times width? It's essentially variables. If I'm solving for area, I don't have a number, right? So I do have area equals length 4 times width of 2. Start with the formula. Start with the formula, start with the formula, start with the formula. I say it 100 times, right? Then plug in the numbers you know and solve it. Really, this whole problem breaks down into 4 times 2. So area equals 8, and then I need a unit. Well, since it is area, it's not only going this way, but also this way, which means it's going to be foot squared. So there's my particular area there. If I were solving for length of something, that could be 4 foot. But if I added 2 foot, I'm not making it 8 foot. It's not getting longer. What it's actually turning into is I'm increasing into a second dimension, which means this is essentially little squares. So if it were 4 by 2, what I'm really breaking it down into feet is this. And you'll see I have 4 by 2, which makes 1, 2, 3, 4, 5, 6, 7, 8, 8 squares. Take that one step further, and if I'm moving beyond area into volume, I add another dimension. And now I don't have squares, but I have cubes. Okay? So let's clean this up a little bit, and we'll look at it from one more approach. So the formula I'm focusing on today is area equals length times width, and that could also be base times height, right? So what if I did something like this? And I have a different type of shape rather than a rectangle. What I have here is a parallelogram. And I know a parallelogram because it has parallel lines. And parallel lines run next to each other, but they never touch. They never intersect. So I have parallel lines here, and I have parallel lines here. I still use area equals length times width. But I really call it, instead of length and width, I call it base and height. They're the same thing. If I had this rectangle and I solve for base and height, I can use this formula to get me through almost everything in this unit. So this is a formula you need to memorize, area equals base times height. So I have a little slant here, and I'm not really sure what to do with it. So what I create in this parallelogram is a dotted line, boop, and a right triangle. I need a right angle. What a lot of people don't see, though, why I do that is because if I took this, and we're going to make our height here to be 2 feet, just for our purpose. This is important to me because if I were to cut this triangle off and put it over here, clean this out, and I put it over here, what am I back to? I'm back to a rectangle, right? So we need this straight line that comes down here, and almost everything that you're given is going to show you that already. So you don't have to remember to put that in. But now you know why we do that, because we can take this piece off, put it here, and now we solve it as a rectangle, right? So I'm going to use area equals base times height. So area equals base times height. I don't know the area, so that variable comes down. My base is going to be 4. My height is going to be 2. And, of course, area equals 8 foot squared. Well, let's ask ourselves, what if they change it up on us and we do this? equals base times height, and my area equals 12 foot squared. I use the same formula, and what I have here is h. I need to solve for height. When I'm thinking about these as variables in an equation, I solve them the exact same way that we did in the previous units, right? Area equals base times height. Start with a formula. Start with the formula. Start with the formula. The formula tells me that area equals base times height. I'm going to substitute what I know. Area equals 12 is going to be equal to, well, we'll change this to base, sorry, so that's accurate. Base times my height of 2. Well, this turns into an equation that we solved in the last unit, right? 2 times something equals 12. Well, instead of multiplying by 2, I would divide by 2. And I get 6 foot is the base. Because it's just the base and not the whole area, it's not foot squared, it's just foot. I go back and I check my work. Is 6 times 2 12? And it sure is, so I know that I'm correct. So let's go ahead and look at one more. Again, the formula that you're solving here in your book, area equals base times height. And they'll write it as BH, because when we have variables next to each other, we know that that automatically implies multiplication, right? So what I end up with here is use the formula area equals base times height to solve the area of the parallelogram. Again, parallelogram because I have parallel lines. And you'll notice that I have my straight line here, and that's what I'm measuring my height off of. Because if I were to take this triangle and put it right here, I'm back to a rectangle. That's why it's the same formula. Area equals base times height. They wrote it down here. I'm going to rewrite it up here. Area equals base times height. I don't know the area. That's what I need to find. My base is 6 3/10. My height is 2 1/10. It's the exact same thing we did before, but now we're just adding decimals. If I'm multiplying with decimals, I want to double check my work. So I would estimate 6 times 2 is 12. My answer needs to be somewhere in the ballpark of 12, right? So I come over here and I'm going to do 6 3/10 times 2 1/10. 1 times 3, 1 times 6. Add my 0. 2 times 3 is 6. 2 times 6 is 12. And 3, 2, 3, 1. And I get 1,323. 1,323. And that seems weird to me because I ballparked my answer should be around 12. There's only one way that I can have this anywhere near 12, and that would be to put my decimal here. But if I double check it, 2 digits to the right of a decimal in my problem, 2 in my answer, right here, the area equals 13 23 hundredths. So let's take a look at one more, and then we will be done. Find the area of the square with sides measuring 9.5 centimeters. They're going to give you this formula for a square. The area equals side squared, which is a very quaint way to say this side times that side. And you know what that means? Base times height. Because they're a square, they have the exact same measurement on both. So you could just take that number and square it, which is multiplied by itself. But if we keep this formula, area equals base times height, that's the formula I want you to memorize because that's the formula we're going to be using over and over and over again. Area equals base times height, my area equals 9 5/10 times 9 5/10. The exact same thing we did before, right? So I'm going to come over here and just put 9 5/10 times 9 5/10. 5 times 5 is 25. 9 times 5 plus 2 is 47. Add my 0. 9 times 5 is 45. 9 times 9 is 81. Plus 4 is 85. And I'm left with 5. I'm left with 12. I'm left with 10 and 9. 2 digits to the right of my problem. 2 in my answer. I get an area of 90 25 hundredths. Now, if you were to take a calculator and actually put 9.5 caret 2 or squared, you're going to get the same answer. So rather than trying to memorize all these different formulas, let's keep it at one formula that will get us through all of these. All right? So again, start with the formula we're finding for geometry. It's really just taking a formula and realizing that those are variables that I can substitute my number in. Substitute your number, solve it the full way through, and then check your work.